This is just a brief video about the upgrade to our Jayco Journey battery system. So we've just recently picked up our Journey. It came with a Projecta PM235J system already installed. That's the battery charging system down here. And we weren't expecting it, but it came with a 100 amp hour AGM battery as well. So I didn't really want that in there just with the weight, and 100 amp hour AGM, you're really only getting 30 or 40 amp hour of usable power in that before you ruin the battery if you drain it too much. So I wanted to upgrade to a lithium, which this particular model of the Projecta allows you to do. You can get in there and change the charging profile via the app, so that's not a problem. But I've done a few other mods as well. There is a separate video regarding the hot water unit and 12 volt pump that will appear up somewhere on the screen there, a link for that. So this is just more about the power side and what I've done there. So I'll quickly run you through a few of the mods that I've done. Okay, this is under the rear bunk. So this is where the Projecta is mounted out of the factory. So that unit was obviously already there. There was a similar battery case to this, but it was actually mounted over there that had the AGM in it. So it looks like a big mess at the moment, but I'll run you through what all this stuff does. So basically this is a lithium battery, 150 amp hour. Inside here is a 125 amp hour lithium battery pack, which I've built. I built both of these off some old solar batteries. Anyway, this one is in this pack because it's removable, so I can put it in the back of my car when I go forward driving. That's why they're different shapes, I guess. So this is the charging cable. So this cable and this cable run down to the BM, sorry, not the BM, this is a PM235. So they connect to the charging port here. There's the charging cables. So they charge the two batteries. Down here, as you will see if you look at my other video, there's some pump control cabling. So this isolates the pump and the hot water unit at 12 volt supply. This is actually to turn this 2000 watt inverter on and off. So the way I've got that inverter wired, from there is a single plug, so basically it's going to give me 10 amps at 240 volts, and that is wired through a safety switch down to a weatherproof socket under the van. So what I can do is, if I pull up somewhere and there's no mains power, I can just plug my normal 15 amp lead into the socket that's under the van, and then plug it into the caravan input, and that basically fires up all the 240 in the caravan. It'll run the microwave, it'll pretty much run everything in here except the air conditioner. So in total there's about 275 amp hours here of lithium power. Most of that is usable. Now what I might do is actually get rid of this. I'll pull this out just so I can have a better look at what's going on inside this box down here. I just thought I'd mention that by plugging the inverter into the van, that works fine, but what I do have to remember to do is unplug the charger lead from the 240. Otherwise I'll be charging the batteries from the batteries, if you know what I mean. So as long as you unplug this, the Projecta unit will still run via the 12 volts, but it just won't be trying to charge off the mains, which is actually being run off the inverter and batteries. So what I've got here is I have two isolators for the solar inputs. So this isolator brings the solar directly from the roof. So I'll put two 200 watt flexible panels on the roof. They run through here, and then they actually connect to the solar input here on the Projecta unit. This unit what I've done is put an Anderson plug at the front of the van, and that just runs through here, so I can connect some portable solar panels if I need them. Then from here I've actually put in a DC-DC charger, just a smaller 20 amp one, so they run from here, connect into this, and as well as that I've taken the vehicle lead, so from the vehicle charging, which would normally connect into here, the vehicle battery ports, I've taken them out and put them through here also. So basically when the car's running, instead of charging through this unit, I'm charging through this unit. Now why would I do that? The reason is when the vehicle's running and you're charging through the projector unit, it doesn't charge via a stage, like a 3 or 5 stage charging cycle. Basically it just trickle charges your battery, which is fine. If I left the AGM in here, that's fine. Because it's the lithium battery, I don't want to just charge it 24/7 when I'm running the car. So basically this will take the charging current from the car, charging voltage, sorry, and stage it properly for the lithium batteries. So anyway, from there, then obviously we come into here, and we've got a positive and negative connection. So there's just like buzz bars, basically positive and negative bars. So the charging voltage from here will come and connect onto here. Now then these connect to the batteries. So off the positive bar, we've got a cable going through 120 amp DC circuit breaker, and that is for the battery unit that I've just removed. And there's obviously another set of cables that run through a 200 amp breaker that comes out and connects to this battery. And both of the negatives run via a projector shunt. So this is a shunt with a comms cable that connects to the projector unit and tells it the current being drawn through the shunt. So any high current loads you can run through here. That's the whole point of it. So obviously the DC-DC charger. I've got the direct connection for the 12 volts for the hot water unit through here. That's 25 amps. So that runs through these bars as well. And then any inverter that you want to run, you need to run through the shunt, because it won't run through this unit. Only low current loads will run through this unit. So I've got obviously a cable coming out here through a 250 amp fuse, and that runs to the inverter. So it looks like a bit of a mishmash in there, but it all serves its purpose. And obviously I have a cover to go on there just to tidy the whole thing up. Now the other thing you may wonder is, why do I have two connections from the batteries? So basically this connection and then this connection here, they run to the projector unit. Now they run through the BMS systems of these batteries to balance the charge across all the cells. And the reason I've got these other connections is obviously for the high current output, because there's a restriction through the BMS of a 40 amp output. So these connections don't run through the BMS. So the reason I've done that is because this inverter, if there's a large load on that, will pull more than 40 amps. So I've run those connections. Obviously I've put them through breakers, and they run direct to this buzz bar, which then runs the inverter. That's just the way I've set this up. Now, it's not ideal to not have them coming through the BMS, but as long as when the unit is charging these batteries, it balances the charge while it's charging, I'm happy with that. And realistically, this inverter won't be used that much, and so in essence these won't be used that much. Most of the power is going to be just low current 12 volts through this unit, in which case the power will be coming through these cables from the BMS connection.